Hey, my name's Joey Henderson. I've been in the HVAC business for 30 years. I've been an instructor for about 25 years of those, as well as a contractor. I've worked with manufacturing on the technical side, on the training side, and also out in the field. And one of the things I do is I run a program where I use the iConnect training, and also I use the iManifold. And today I'd like to show you 6 lessons that I teach with this 406C trainer. Also, that's helping me is Nick with iConnect training, and Nick is going to be my my hands and feet down there, and he's going to show you what I would normally do with this trainer. So, Nick, if you would, what I want to do, the first thing I'd like to do is I want to show the different components here in the HVAC system. You know, a lot of times we do the training where we draw it on the board, and that's all the students got. Well, here now we can actually show where those drawings go physically into a unit. And we've got a complete heat pump system here, which is fantastic. Not only that, we've also got a duct system on top so we can do airflow diagnostics. And we've got our own easy trap there, which is a trap that is used constantly anytime a unit is above a conditioned space. We've also got a drain pan as well with an emergency float switch. And all of these are critical for the student to understand that they are a necessity. And we can use this trainer to show how to wire those in as well. A lot of times what I do is I will take those wires out and let the student wire those back in, and then we'll test it and see if it works. I always tell them that if they let the smoke out, then, you know, it won't work anymore. So we always got to keep the smoke into the components. All right, so Nick, if you would, let's go over here and look. We've got a split system here. And first off, Nick, go ahead and put your hand there on the outdoor unit. Now, this outdoor unit has got inside of it the condenser coil as well as the compressor and all the controls that are associated with it. And on the board, we may just have the 4 major components broken out into 4 sections, but here it's all inside this outdoor unit. So there's the outdoor unit. So Nick, from there, if you would put your hand on the indoor section, and this is the air handler. And if you look, the air handler has plexiglass in it, so we can actually look inside the air handler as the unit's running. On the bottom of it there, you show Nick that we've got the indoor coil, and that is an N-shaped coil. It's actually 3 coils in one. And then on top of that, you can see the blower section. And we've got the controls there. You'll see the transformer, you'll see the fan board, and all that operates that indoor section. So we commonly call this piece the air handler. And it's called air handler because it handles the air. And then on top of that, you've got the ductwork. So Nick, if you'll show that, we've got the supply ductwork on top, and then we've got the return duct on the bottom. And on the side of it is a filter grill as well. And you can use that to show how different filters affect airflow through a system. Also on top on the supply duct, if you'll point to that damper up there, Nick, we've got a manual damper where we can adjust the airflow through the entire trunk line. We can also adjust the dampers there on each individual register. You can take this and modify it. One thing I always like to tell people is that I've taken ductwork and taken out the end of it and extended it, and I can have students extend it. We can add things to it. We can take off the registers and add transitions to go and use flex duct. So you can take this basic model unit, which in itself has got a lot to it, but I've actually expanded to it, especially on the airflow side. And I really like that with the air in it. Also on the side of the unit there on the air handler is the troubleshooting box. And just to let you know, we've got some great training videos that explain this, but over there where Nick was got, it's got a flip on it. And there are troubleshooting scenarios that you can turn the switch on and let the student go and figure out what's going on. And we're going to talk about that. So with our 6 lessons, the first thing I want to do is I want Nick to go through the cycle, the refrigeration cycle with that unit. So if you'll go down there, Nick, go down to the service valve down at the bottom.
Yep. So the compressor's inside, as we talked about, going right to a reversing valve. Then it's going to flow through the condenser, then through our liquid line, which is going to come up. This is where we've got another fault right before the filter dryer, where we can simulate a restriction there, forcing the refrigerant through capillary tube. We've got a sight glass to see that liquid refrigerant. Then coming into the air handler, our indoor TXV is right inside the plexiglass cover through our evaporator coil. And then it's going to come back through our insulated suction line. Coming back down, here's our low pressure service port here, and then back into the compressor.
All right, good job. We've identified the 4 major components, which is the condenser coil. So go ahead and put your hands on there where the condenser is located. There, Nick. The coil itself, right on the outside. The other major component is the compressor, which is on the inside of the outdoor unit there. And then we've got the indoor coil, which is the end coil there. And then we got the meter device. And Nick, the meter device is right there in the back. So we got the 4 major components. And Nick just went through the cycle. Now, one of the things that I like to do as a lesson is as you go back through, you talk about the condition of the refrigerant in each of those lines. So Nick, we go back down to that liquid line service valve down there. And
okay.
as we go through it, we'll describe that it is a high pressure subcooled liquid leaving the condenser. And as it goes up, Nick, you go up to the filter dryer there. Then you talk about the filter dryer, how not only does that filter refrigerant, but it dries it out a little bit. One thing I like about HVAC components is they are named for what they do. So if you want to know what they do, just look at the name of it. So a condenser condenses refrigerant. A filter dryer filters out debris and dries out some moisture. As it goes through that filter dryer, it then hits that sight glass so we can actually see the condition of the refrigerant. Like Nick said, if you look behind that filter dryer, there's a valve right there. And as Nick would close that valve off, we would simulate a restriction, and the students can actually see how the liquid refrigerant changes through that sight glass as that restriction builds up. And to see that real time, students love it. So we'll go through there. We'll leave it as a subcooled high pressure liquid. And then you come around and you follow it through, Nick, to the indoor coil. Now, as we're in the cooling mode, that indoor coil is the evaporator. It hits the meter device in there, which is a thermostatic expansion valve. It goes through there. You can take time to explain what an expansion valve is and how it works. Hits the evaporator coil. When it leaves the evaporator coil, it comes out as a low pressure superheated gas. It comes out, follows back through there, and Nick, as you can point to, we got Armaflex all over that suction line. And that's because that suction line gets cold. We don't want it to absorb any more heat from the outside air, and we don't want it to condense and cause moisture problems on the ceiling up in the attic. And then as you see, it comes back and enters into the suction line service valve. And you can talk about the service valve right there as well. And then it goes back into the compressor. There is a common suction port as well. And I believe that's right between the two there. Is that right,
Yep.
Nick?
Yep.
So that's important to explain that a heat pump has a common suction port. And the other thing too with this trainer, it is a heat pump. So you can, not only can you go through the air conditioning side, we can also go through the heating side. We can show how the reversing valve shifts back and forth as well. And that common suction port is where they want to hook up to always have suction, whether it's in heating or cooling. So the little line and the big line, the little line is the liquid and the big line is the gas. That's always true whether in heating or cooling mode. So the lesson I wanted to show for number 1 is the importance of the condenser fan motor and how important it is to get air. So when we're in the air conditioning, the great definition of air conditioning I like is removing heat where we don't want it and getting rid of heat where we don't care, okay? So as you go over and you turn that unit on, the indoor fan starts blowing and it's going to be pulling air through the return. So you go over there and you can have the students feel that air as it's pulling to the return. I've taken a piece of paper. They can see how it sucks it up through there. And as it pulls the air into the return box and across the evaporator is absorbing the heat out of that air. And then it takes that heat and absorbs it into the refrigerant. and it goes to the condenser. Now it has to discharge all that heat in the refrigerant out of the condenser. So if you put your hand over top of the condenser, you can feel that hot air coming out. That's a quick check, right? Make it it's working. Now, what happens if we lose the condenser fan motor? Well, if we go over, and I got the students there, and we've got the gauges going, we got them on the screen, got them on our iPad, we can see the normal operating pressures. And I go over to that box over there, and I flip the condenser fan motor off, kill it. And then, and before I do that, ask them, what do they think is going to happen if we lose the fan? And then as they kind of ramble through what they think is going to happen, then I have them explain why they think that's what's going to happen. And so we get into discussing heat transfer, we get into discussing condensing, saturation temperatures, and how that affects the cooling. So we flip that fan off, and then we'll watch how the pressures go up, and almost immediately on that head pressure. And as that happens, we're not going to be rejecting the heat off of that. We're going to be retaining the heat. And eventually you'll see how the evaporator coil starts getting higher in temperature as well. The other part two of that lesson is you can talk to them and ask them what would make that indoor fan fail or the outdoor fan fail. What would make the condenser fan fail? And we can talk about whether it's a capacitor or whether it's high voltage going to it. We can take the cover off there and see that the contactor is pulled in. We can rule that out, talk about how the contactor controls the compressor and the condenser fan as well. So that's lesson number one, is when we kill the condenser fan, how does it affect the refrigerant cycle? And secondly, what are some of the things that would cause that condenser fan to go off? And then we'll flip the switch back on, fix the fan, flip the switch on, and watch the pressures come back up. Currently, as we look through that, the second lesson is talking about what heat transfer actually is. So we got the gauges going, we got the fans running. We turn the outdoor fan off and we notice that pressure goes up. Well, why is that? Because we're no longer transferring the heat from the refrigerant to the outside air. We quit pulling air across that coil. Now that heat stays into the refrigerant and just cycles back through and through. When we turn the outdoor fan back on, we'll notice that we're going to blast the hot air out of the top of that. And that's actually the heat transfer that we're doing. We can also measure the return air coming into the unit and measure the supply air leaving with our temperature sensors there and watch that TD. Not only are we looking at the temperature drop across it, dry bulb, but we can monitor the wet bulb drop across it as well. That talks about two discussions of two types of heat, sensible heat and latent heat. And with us measuring the dry bulb and wet bulb, we can see the removal of both types of heat. Talk about the sensible heat as heat we can measure with the thermometers, and latent is what we measure with a psychrometer, which is what we have here, and they'll measure that wet bulb drop. Now, what happens if we kill the indoor fan? So we've got a rheostat on the side of this unit, and we can slow the indoor fan to represent a filter getting dirtier and dirtier, or we can just turn it all the way off and represent a failed fan completely. And you will see that the heat transfer changes there as well. The coil starts getting colder because it's no longer absorbing heat because we're not moving air across it. So second lesson is showing how the heat transfer works and using the fans to show how it will affect the refrigerant capacity, the refrigerant pressures, and the temperature drop as well. Lesson 3 we're going to look at is explaining the difference on the traps. So you look down there at that condensate trap, and Nick, you'll point to the depth of that trap there. Okay, see how it comes down and comes back up? There is a particular reason for the dimensions of those traps. This trap, you can point out, is on the intake side of the motor, the blower motor. So you look at the blower motor, it's up top of the evaporator coil. So it's pulling air through the evaporator coil. Well, it's also pulling air through that condensate trap. So it is important that we have a deep enough trap so that when it starts trying to fill it with water, we just don't pull that water back up out of the trap. So that trap is a specific dimension, It's also a very common trap called an easy trap that is on a lot of air handlers out there, and it's got a safety in it. That way, if that trap begins to plug up and doesn't no longer drain water, that safety will take the system off before it fills up with water and spills out into a conditioned space in a basement or into the auxiliary drain pan. Now, if it does spill out into an auxiliary drain pan, then we also have a safety switch in the auxiliary drain pan, which is in our drain pan here. And we've got that to simulate that. And we've got a safety switch there on that auxiliary drain pan. So we've got two safeties, one for the trap and one for the auxiliary drain pan. And with this system right here, we can show that as we run it, depends on what condition your system, your unit's in. But if I got this unit out in my lab and I get it really nice, I open the doors, it's summertime, and I let some heat and humidity in that lab, then this indoor coil begin to produce a lot of condensation. And when it's first started up, that trap is dry. And you'll see the water start to build up inside the drain pan of the evaporator coil because it's plexiglass, and you can see that happening. I take a moment also to explain that in the field, to troubleshoot condensate problems, you can take the metal doors off of the unit in the field and put plexiglass on it, just like we've done here in this trainer, and really use it to troubleshoot real world problems out in the field. And a lot of times that's due to improper ductwork. So here we can actually simulate that same thing. And then once we start drawing that water up, that might be the first cycle of the summer. But then we can satisfy the unit here and watch the water fill up in that trap. Then run it again, and you'll watch it drain steadily with no problems. As it fills up our drain pan, we can watch a drain pan fill up, and it'll take that safety out for us. So we've got a couple of things we can do with that lesson to show what a draw-through condensate trap does and the purpose of it. All right, Nick, if you would go ahead and go to the T6 thermostat that we have there and put it in the cooling mode. And then go ahead and turn down the temperature so it'll come on, and we'll watch the pressures on the system. All right, there we go. We can immediately see the head pressure going up, the suction pressure coming down. We'll start reading the superheat and the subcooling as it settles out. But we'll let that run just a minute there. Now, you know, for lesson number 1, where we lost the condenser fan motor, I wanted to see what happened to the head pressure. But right now, you look, and we got about 148 suction and about a 225 head, and it's still going to go up some more. All right, well, Nick, go ahead and go to the troubleshooting box and turn the outdoor fan off, and let's watch those pressures.
So that just killed the condenser fan.
All right, now watch that high side immediately start reacting to the change. This is where the students start believing what we're telling them in the classroom. And it begins to go up and up. And look at the suction pressure. At the moment, it's staying the same, but eventually it's going to start going up because we can see that the heat is not being transferred now out of the refrigerant, but it's being recycled back into the evaporator. The only thing that's helping us out here is we got an expansion valve, and you can see how that expansion valve is trying to maintain that superheat like it's supposed to do. But look at there, the head pressure keeps going up and up. Now, Nick, if you would, go ahead and flip the fan switch back on, and let's get the condenser fan back in operation, and let's watch it and see what happens to it. Look at there, we've got an immediate change of pressures. So now we've got heat transfer going on again. And if a student was to put their hand over that unit, Nick, then we would actually get that heat starting to come off of that condenser again.
All right, we're going to have to, I've got R401A, not R410A. I was looking at the saturation temperatures and nothing was making sense to me.
Oh.
So that's Let me just change that.
Now, really, Nick, you got the sensors on it, right?
What's that?
I said you got the sensors on it. What is the? Oh, okay, it's 66 degrees in the shop there. So let's talk about that for a minute. So Nick, I want to talk about the data that you have right there at your fingertips for this unit on the app. So you've got on the left side there, you've got your suction pressure. You've even got a visual indicator of where it is on a gauge on the outside edges. Also, you've got your saturation temperature right there with the pressure. And on the high side, you've got it. So we're looking at on the high side, we're running about 226 PSIG, and that is showing about a 77 to 78 saturation temperature. So immediately the students can see that as it's operating. And right below there is where we've got our SLT, which is our suction line temperature. We've got SH, which is our superheat. ODA, which is our outdoor air temperature, which is the temperature right there in the shop. Subcooling, which is SC. And then we've got our liquid line temperature. And with that information, we can actually come up with the superheat and subcooling. The more this unit runs, the more these numbers have changed. The one thing that I always like to tell instructors is that these units, the outdoor and the indoor, are in the same environment. So students got to understand that some things are going to not be the same whenever they get out in the field, and that outdoor unit's actually sitting in a 95-degree outdoor setting, and the indoor unit's in a, say, like a 78-degree indoor setting. So Nick, can we get back to the gauges? There we go. Okay, now with that set up right there, Nick, I want you to go ahead and show what happens whenever we turn the outdoor fan off. So go ahead and take the dial there and dial it back to about 50% airflow to show what a restricted filter can do.
We're going to go with the indoor fan reduction?
Yeah, indoor fan reduction to about half, about 50% airflow. Now keep your eyes on the suction pressure and temperature, and then also at the same time the superheat. The suction pressure is immediately dropping because it's no longer absorbing heat out of the air. This is what a dirty filter does to your unit. Now, if you look down the superheat, it's staying fairly constant because the expansion valve is doing its job. The expansion valve is maintaining superheat, but the more the system runs with that dirty filter, we're getting close to freezing. So we're at a 37-degree evaporator coil right now. Now, Nick, go ahead and turn the fan down even further. Let's let that filter get even dirtier. And there we go. We're getting down to 109, 108. Look at the evaporator temperature, down to 33, 32. Once it gets below 32, whatever condensation's in the air will eventually begin to freeze up on the coil. Again, look at the superheat. See, the superheat staying very, very much the same because the expansion valve is metering back the refrigerant, trying to keep it from flooding that compressor. Eventually, it's going to get overcome, and we will start getting a lower superheat. Now, Nick, go ahead and change the filter and raise the airflow back up to normal. So we pulled out that dirty filter, we've thrown in a clean filter, and look what happens. We get full airflow again, and you can see that pressure starting to rise and the temperature starting to rise. And why is that? That's because we're now moving warm air back across the evaporator coil, and we're moving the right quantity of air. Before we weren't, because we had a dirty filter. And that's what we just represented with lowering the airflow. So this is another thing you can do, is use these gauges and all this data to show real-time changes as we simulate conditions out in the field. Things I can't do on a board, not near that easy. Okay, now Nick, as we're looking at it, and we'd be collecting condensation in that drain trap, you could put your hand underneath that drain, and you could actually feel it sucking air. One thing you could do to show the students that is you could take a piece of paper or a tissue, and it would actually draw it up against that trap, and you would show that that trap was actually in a negative pull. So one thing I want to show too, Nick, is that whenever we've got the airflow lowering down, you can also look at the temperature changes across the evaporator from the return to the supply. So we've got those numbers we can show, Nick. Okay, now there we go. So you can immediately see we've got a return air dry bulb of 71 degrees. Our relative humidity is 28%, and our wet bulb is 53. And then if you go down, Nick, if you got your both return and supply there, go ahead and lower that fan speed again. And we can keep our eye on the temperatures and watch how they change. Now watch real carefully the supply air temperature. See, our relative humidity is starting to change, our supply air, our wet bulb starts to change. All that is affected by how much air we're moving across that coil. Now go ahead and turn the indoor fan all the way off. This is going to simulate a loss of indoor fan. The one thing you'll find out on these trainers too is that as we operating, you got to give it a minute to adjust because the fact that the indoor and outdoor coil is in the same load conditions. Now we can see how the relative humidity and the wet bulb is changing on it. There goes our dry bulb changing on it. So we've got an immediate change due to no airflow. So we've gone through lesson number 1, which is the importance of the outdoor fan and also troubleshooting an outdoor fan failure. Lesson number 2, we talk about the heat transfer through the coils and raising and lowering the airflow to show how that heat transfer is affected by airflow through there. And then on lesson number 3, we're talking about the necessity of a trap on a draw-through coil, and also the easy trap and how important it is to have it with the float switch, and auxiliary drain pan, and how to wire those in. Lesson number 5 is measuring the dry bulb and the wet bulb across the evaporator coil, explaining what dry bulb and wet bulb is and what it means to comfort, removing both sensible and latent heat. Now they're affected by a dirty filter, a dirty low airflow, basically, and simulating that in a couple of different ways. And then number 6 is I wanted to explain what kind of motor we have in this air handler and how that works. So Nick, if you'll go over to the indoor blower motor and point out the capacitor for that indoor blower motor there. Okay, now that, there you go. So that's how we know that that is a PSC motor, a permanent split capacitance motor, that it's got that capacitor in there. We can clearly see it. All right, so Nick, what I want you to do is we'll have an amp meter on the motor itself to see how it is affected by airflow. One of the things that I like to teach students, and what's great about this 406C, is we can see how to measure the effects of airflow on the motor without having to take out a lot of extra instruments. So for instance, you reach up there and you can create a restriction right there with that damper. So go ahead and adjust that damper a little bit just to show how it works. And what we're simulating there is an increase in static pressure. So that would like simulate a too small a ductwork. And then the student can actually see the effects of the amp draw on the motor itself. And so that was one of the things that I really like about this trainer. We can show that. And then if you reach up there and open that damper back up, Nick, then they can see that the amperage on the motor will actually increase. So that shows how when you have more airflow going across the motor, it's going to pull more amps, more current. But as we have more restriction in the ductwork, a lot of students would think that the amperage would go up because the motor is working harder against that restriction. But the reality is it's working less because we're moving less air. So when you close that damper down, you can actually show that in real time with the amp meter. The other thing too is it shows, again, low airflow, and we would watch that change on the gauges as well that we're seeing here on the screen. And they would see that on the big TV screen as well. So let me recap there, Nick, on our 6 lessons. Lesson number 1 is the outdoor fan and how it works and what its purpose is. Lesson number 2 is going to be the heat transfer through the indoor coil and the outdoor coil, and how refrigeration, that is what it actually is, in essence, is transferring heat from the inside to the outside, or in the heat mode for the heat pump from the outside to the inside. Lesson 3 is we're talking about what a draw-through coil is, which is what we have here, very common, and the need for that condensate trap, the need for an easy trap that's got a built-in float switch, and also the safety switch in the auxiliary drain pan, and how to wire those two together in series and let the student see the wiring, trace it out, and then unwire it and let them wire it back in. Lesson number 4 is the operation of the easy trap. You can pull out the safety switch, show it how it works. You can fill it up with water and then block the drain and watch it actually open up and take the unit off. You can also then let the auxiliary drain pan fill up. And when it gets to a level, watch it take out the unit as well on safety. And then you can have the students wire it up and then test it and see if they did it right, see if it actually takes the unit out. The other thing was number 5, which is measuring the wet bulb and dry bulb on the return and the supply, showing how that's affected by airflow, explaining what sensible heat is, what latent heat is, and seeing what dry bulb and wet bulb is. A lot of people have no idea the importance of measuring wet bulb. And this trainer will show the very, very important how that is removing moisture, which is the #1 load on the air conditioner, is removing the humidity. And then we can drop the temperature. And we can show that with lesson number 5, measure the wet bulb and dry bulb. The other thing, Nick, if you point down there again to that filter grill, open the filter grill up, Nick. So we will explain what a filter grill is to a student. And it is a grill that you can open up and put the filter inside of it. And then you can see there that Nick's got one type of filter. You can create an entire lesson plan off of different filters and how they affect airflow. And you can use that. And so Nick, go ahead and put that filter back in. Also, Nick, point out the arrow on the filter. And it shows that there is a specific direction that the filter goes. And we can point that the arrow always goes into the direction of airflow. And then get all kinds of different types of filter and put it in that filter grill. And they can see it affect pressure, they can see it affect temperature, they can see it affect the wet bulb and dry bulb going across, the airflow, all kinds of dynamics. A lot of people forget about filters. They think it doesn't matter, just put one in and go with it. Not true. And there's a great way to prove it. And then the last thing we was talking about was the effects of the motor, and different motors react differently to restrictions. And we talked about that PSC motor. And now you can see how airflow affects it. You do a quick amp draw on it and see for yourself before you pull out anything. If it's moving 100% airflow, then the PSC motor will be pulling 100% of its amp draw. But if it's moving less air, then it'll be moving less current, through the amp meter, and the student can quickly see, they can do an airflow check or an airflow idea just by pulling the amp draw on the motor before they pull out all the other airflow instruments. And that's our 6 lessons for the TU 406C, the iConnect training.